So again, this week, we'll eventually play in Khan Academy. For now, we're going to play in Geogebra. And then in class on Wednesday, get a piece of paper, draw as big a circle you can on it, and cut that circle out, and then we'll play around with the activity for the week. So back to the Geogebra app here. So I'm just going to clear this out. And sometimes I do want to save my work, other times I don't. So just, it's up to you. If you're just messing around, you don't have to save it. All right, so again, the idea behind Geogebra is here's this flat plane, like a piece of paper that we can play around with and share stuff. So what I'm going to do is just plot 3 points anywhere on the screen you want. And Geogebra does have a smartphone app and a tablet app, but I find them a little awkward to use. Tablet one's, I think, a little easier than the smartphone, and you should be able to use it from any computer or browser. Then from there, what I'm going to do is I'm going to look for the ray tool next. So I have, it's not in my basic tools, I have segment, I have line. Just want to scroll down, and if you don't see the line section yet, that means you need to keep scrolling down and hit the more button. So at first, you get this set of tools. More gives you more, in which case you should find the ray in the line section. And it says select the starting point and then any other point. So the first point for array is always the starting point. Doesn't matter which one you call your starting point. I'm going to pick B to be my starting point today. And then if I go over to A, it'll continue the ray through A. So this would be the ray BA. And then I'm going to keep B as my starting point, and then I'm going to make another ray through C. And whenever we have two lines that meet, then we kind of introduce this new idea related to the space between the lines. So if I were to switch up here to the move tool and grab point C, I can change how close those two rays are or how far apart they are. Now, it gets kind of weird because I can keep moving around in the other direction and I can make them get close again, but then from the other direction. So these two rays have a common point here, and we call that point right there the vertex, where these two rays come together. And then the idea I'm thinking about here is the idea of angle. When we have two rays that have a common vertex like this. And I can use that point C to swing around, kind of making a circle. Now, I'm not making a very neat circle, but I'm kind of making a circular motion here. And so here I would have a narrow or small angle, and then the angle gets bigger and bigger and bigger and bigger and bigger and bigger and bigger. Now, measuring angles, there's a lot of different ways to go about doing that, and different computer packages do it differently, but often we use a protractor when playing on a piece of paper. So you may remember these from school when you were younger, or maybe they looked more like this plastic bird, this one right here, like a see-through plastic thing. But they give us ways to measure an angle. So let's play around with Geogebra's ability to measure an angle here. So if we scroll down in the list, there's the measure section, and the measure can do an angle, a length, which is a distance, or an area. So I'm going to choose the angle one. Oops, sorry, I'm on the wrong page. I'm going to delete that one. I want this one. All right. There we go. So measure, I have angle. Angle with a given size, that's a different idea. Distance and length and area. So I want to try the angle here. And it says select 3 points or 2 lines. So we're just going to want to play around and get used to how this program works. So again, when you click on it, it tells you what to do. Select 3 points. Okay. 1, 2, 3. And it says, hey, here's the measure of your angle. Now, sometimes due to the orientation of things, it might be blocked. You can always get the move tool and click on that text and try and move it to a place you can see it. So it says the angle I made is about 35.5 degrees. And if I were to, again, use the move tool and adjust point C, Now, as it doesn't matter how far I move point C out here really on the line, what matters is whether the points A and B are to make the ray closer. And I can get right on top of A, and if I hit it, just hard to do, I could get 0. Hello, Amy. So the order you click on the points matters. So the first time I did this, I clicked C, B, A, and I got that to happen right there. Geogebra has an undo and redo button, so I'm going to hit undo here and undo again. So I'm back to without that measure. And I can go the other way. I can hit a, oops, helps click on the angle tool first. So that's another thing. Sometimes I click back and forth between tools, like I need to move something and then I want to measure again. Whenever you click on something with the move tool, it's kind of like right-clicking on it. It gives you options. Like, hey, do you want to change the color? Do you want to change the shape? Do you want to change the text? Do you want to just delete it or something else? So everything's editable, which is good and bad. Good, you can make lots of stuff happen. Bad, you can make lots of stuff happen. All right, so back to the angle measure. So I'm just going to click on the points in different orders and see what happens. So this time I'm going to go A, B, C. Okay, it did the same thing as it did before. I'm going to undo that. But if I try C, A, B. Okay, so there it does something pretty different. Put the angle in a different spot. So one thing to note about using the angle tool is the middle point that you click on for the 3 points, that's where it's going to measure the angle from. So the middle angle is the central focal point of the angle. So I'm going to do that one. And then again, sometimes it'll make the angle where you can't see it, and so you can always move it by clicking on it and dragging it and putting it in a new spot. Now, that's a little different from the angle with a given size. The angle with the given size, if we click on that, it's going to say select leg point, vertex, and then enter the size. Okay, so leg point, vertex. So for example, for this angle right here, A is a leg point, B is the vertex. Over here, C could be a leg point, and B could be the vertex. So I'm just going to make, let's say, a new line up here. And so to use, I think any tool that has points involved, you can either select existing points, or if you have that tool selected, it will make new points wherever you click. And so if I keep clicking around the page, it's just going to make points and lines all over the place. So you got to be a little bit careful. Some kids will go a little crazy with that. All right, so I'm going to go back to the angle with a given size idea and think about that. So select leg point, vertex, then enter size. Okay, so maybe I want this to be the vertex right here. So then this would be the leg point, this would be the vertex, and then it says, okay, make your angle. So it says right now, it's saying, do you want to make a 45-degree angle counterclockwise? So I always have to think really hard about this. Okay, so let me see. I went from E to D, and if I go counterclockwise, then I believe what it's going to do is it's going to measure the angle up from E, centered at D. So I'm just experimenting here. So I'm just going to hit OK and see what happens. So what happened, if I move down the page, is it made a new point up here. It's calling E prime. See E with the little hyphen dash thing next to it, apostrophe. And imagine a line connecting D to E prime, and that is what's going on here with this angle. So I'm going to make a ray from D through E prime. And so that line now shows my 45-degree angle. So it makes the point because it needs 3 points to measure an angle, but it doesn't draw the line. You could always put that in there. Other interesting thing about the angle with a given size, the point E prime is on a circle with the same radius as D to E. So just to demo that for fun, let's see, circle with center. If you go down to that, it says select the center point and then a point on the circle. So if I start at D as my center, and then I click on E, then I should find that point E prime is on the same circle. So I don't know if any of you in high school or elementary school or middle school played around with a compass at all in school. Show you what a compass looks like in case you have no idea what I'm talking about.
I have.
You have? Okay, show me a picture, please, of a compass. Not that kind of compass, this kind of compass right here. So you can find these in, Walmart has them and any office supply store will have them. It's got a little pointy part that sticks in the paper and then it has a pencil part over here. So you can use it to draw circles. You can use it to measure stuff. There's lots of things you can use it for. So the idea, a lot of the things about the way GeoGebra works are related to using a ruler and a compass, which years ago, way before my time, and even through my time, that's kind of the way geometry was taught, by using a compass and a ruler, which they said to be a compass and a straight edge. And GeoGebra's inherited a lot of that heritage. Okay,
I remember using protractors too.
yeah, and there's some stuff about protractors are going to come up in the book and in the Khan Academy exercises, and we'll use them a tiny little bit. If you don't have one, it's no big deal, because most of what we do can be virtualized on a screen like this here. But sometimes I'll ask you to play with a piece of paper too. But I don't think I'm going to make you use a protractor for anything. Okay, so anyway, we're just playing around with some ideas here. The idea of angle is, oops, I'm on the circle tool. And again, this happens to me all the time. I'm playing with one tool, I forget which tool I'm playing with, and then weird stuff happens. And so you can always undo if you did something you didn't mean to. And then to have the move tool. And like I said before, when you grab something and move it, things will change around it. So I can see how moving B affects the angle when I'm talking about angle CBA here. So let's do some more with angles.